Okay, our topic today that we're going to do is slope, which you covered in Algebra 1 and probably got sick of it in Algebra 1, even though you also did it in middle school too. So you've dealt with slope a lot. It is arguably the most covered topic in the SAT as well. You're going to have at least two pretty in-depth problems that involve slope, and we'll deal with those later in class. But I hope that you really look and think about the idea of what slope is. It's a rate of change. That two things, when you're dealing with a rate, it's change in y over change in x that we're going to get to. And it's two different things. So we're going to cover all the basic elements of this much quicker than you did in Algebra 1. I'm going to go through almost everything about the topic of slope today. Sometimes you saw it written like this. Change in y over change in x. It's the change of y. Whatever is in this y column of a t-chart over change in x, which is everything that's there. It's going to be two quantities. The change of this quantity over the change of that quantity. And I hope that you can think about it in terms of quantities and real life things. This might be a science experiment that we're going to look at. The time and the temperature of a solution. Maybe you've heated up a solution, and at 0, once you've heated it, it's at 143. After 2 minutes, it's cooled off to 138. After 4 minutes, it's cooled off to 133. So that's a science way to use it, and the SAT will a lot of times give you a real life situation. So change in y over change in x is the change in temperature over the change in time, and that's a rate. Another tip for real life situations, this is usually going to be your time. If you didn't figure that out from Algebra 1, your time is almost always going to be right here. Because when you graph it, and I'll show you that next, time moves linearly like this. Okay? So, change in y over change in x. So, for this one, change in y, how do we get from here to here? Minus 5, minus 5. That's our change in y. Negative 5. What's our change in temperature here? Plus 2. Every time we do plus 2. So that becomes our slope. It's the rate of change. It's 5 degrees every 2 minutes if we put labels on it. Okay? So, we could also simplify that to look maybe like this. We could reduce that fraction. You could also keep it like this. Maybe you do it like this. It's also could be possibly like that. Negative 2.5 degrees per minute. 5 degrees every 2 minutes. So that's how you kind of simplify it that way. Okay? So that's kind of just finding the slope or the rate of change for this. 3 ways that you saw slope presented to you. 3 ways that you could figure out slope. One is with a chart like this, or maybe I could do this like that. Remember, you guys have seen coordinate points. We haven't done any graphing really as a group this year, but I could have you graph this and graph this, and you could do your change in y over change in x that way too. These are considered kind of the same thing, points, in an xy format. Okay? So this is one way that you could show it. Our second way of showing it is in a graph. Time and temp. Here's 143 right there, because that's at 0. At 2 minutes, we're here. and at 4 minutes, we're here. And so we can show slope in a graph format. And you guys remember this, right? Change in y over change in x. Rise over run. Teachers would call it that too. That's the same thing. Because it's the change in y, that the rise is negative, but the run is positive. Negative slope, negative slope. So there's our second way that we could look at slope. You could be given a graph and you do the rise and run and figure it out. I could have given you this information this way, and you could have done this and figured out slope from it. Third way. Is equation. Y equals mx plus b. You guys are familiar with that equation? You guys are familiar with that? I'm hoping you remember that that's your slope and that's your y-intercept. Slope, intercept. So that's why we call it slope-intercept form. We did standard form the other day, slope-intercept form now. Okay, so what's the slope? Negative 5/2. X plus, what's our y-intercept? Well, the y-intercept, I made this one easy because it's at 0. Because when we graph, whatever's at 0, there's our y-intercept. And there, I've presented this information as an equation, as a graph, and as a table. Those are the three primary ways to show the same thing. And people use it different ways depending on what they want to see. On the SAT, they may give it to you like this, and they really will. And you've got to then interpret some things from it. And we'll look at that after lunch. Okay? So there is our slope. Okay? These are the main things to know about slope with those three forms. Okay, a couple more little things. Standard form, almost, if I swap these over. But it's not slope-intercept form. Can you put that into slope-intercept form and get it so it's in this form? I'm hoping you can. That's going to be something that you do today. 6y equals negative 8x minus 4. Divide by 6, divide by 6, divide by 6. Because we want y by itself. And there is our answer right there. Simplify these two fractions now. And that's your answer. So putting it into slope-intercept form is a skill that we've got to do. And that's going to be the main information that I put. The other example I'm going to do with you in class that I want to show, but I'm running out of time on this. So hopefully you can always come back to this if you need some help on anything related to table, graph, and equation.